Hi folks, we're going to take a look at page 481, number 28b. So they're asking us to prove this identity. So first thing is to choose a side to start with. And it looks like the left-hand side has more opportunity for some algebra. Not much we can do with that right-hand side. Okay, so here, left-hand side. So again, remember, you can only work with one side at a time since we don't know that these are indeed equal yet. All right, so I notice on the other side of the equation, I just see cosines, and here I've got cosecant, cotangent. So the first thing I'm going to do is use my identities to rewrite this in terms of sine and cosine. All right, so here cosecant is just going to be 1 over sine x, and then here minus cotangent, which is going to be cos x over sine x. Okay, squared, and that's also nice because they've already got a common denominator. So I'll add these together here. So I've got 1 minus cos x over sine x. Okay, and already something nice because I'm seeing the 1 minus cos x. I'm seeing a 1 minus cos x there. There's not much we can do here, so I think I'm going to square numerator and denominator. And I think that's got some hope because sine squared, I know, can be rewritten using cos squared. Okay, which again, everything seems to be in terms of cosine. Okay, so I'm not going to actually expand the numerator yet, before I start doing that much algebra and making it more complex. I'd rather see what's going on with the rest of the problem. Okay, so this is going to be sine squared x, and as we talked about, again, always every once in a while look at the other side of the equation to look for inspiration. And since everything is in terms of cos x here, I'm going to do that on the left-hand side. Okay. So here I'm going to rewrite sine squared using the Pythagorean identity as 1 minus cos squared x. Okay, so now I need to find some relationship to the numerator if possible, because I don't really see what else I can do with this denominator, but I do notice that this is a difference of squares. All right, so let's see where that takes us. 1 minus cos x squared, and this here, difference of squares, can be written as 1 minus cos x times 1 plus cos x. And now I'm seeing some nice stuff happening here because this factor of 1 minus cos x is going to reduce with one of the factors of 1 minus cos x in the numerator. And lo and behold, what are we left with? 1 minus cos x, the numerator, and 1 plus cos x in the denominator, which is exactly my right-hand side. Okay? Meaning that the identity is proved. Okay, so just to recap here, unless I was only seeing, cosecants and cotangents on the other side of the equation, my first step was to just right away write this in terms of sine and cosine. Notice how I did not square it yet. I did not multiply the two binomials. Okay, that would complicate matters. I better to wait before doing something like that. So turn this into sine and cosine, and we saw that worked really well because I had the common denominator. Okay, even when I squared numerator and denominator, I didn't immediately go to multiply the binomials. Okay, I waited to see what else was going to happen, and it turns out that I was able to factor the denominator. Okay, usually better to keep things in factored form than to expand them. Okay, that's it for this one.